So we have Alicia Williams, who's a developer relations engineer at Google Cloud, and she's going to walk us through generative AI functions, right? Big news. We've been talking many questions about that from the keynote. So we're going to look at, you know, how to use them inside standard SQL. Where do they hold up? How can we break them? And what a real workflow looks like in practice. Okay, so this is a recorded session, but she's actually here, so she'll see your messages in the chat. So as she's going through AI functions and all these different predictive workflows, you're going to be able to ask her questions and she'll answer. And of course, at the end, we're going to have a Q&A discussion like we just had here. So Alicia, take it away.
Hello, everyone. Thanks for joining our session on generative AI and predictive workflows with BigQuery. My name is Alicia Williams. I'm a developer relations engineer focusing mostly on BigQuery within Google Cloud. And today I'm here to talk about AI and ML in the BigQuery platform. So I'm going to specifically focus on its capabilities for predictive ML, including some pre-trained predictive models, and also how you can use generative AI and BigQuery for analysis. And I'm going to demo these capabilities as well. So before we dive into the details, let's talk a little bit about BigQuery as a platform for AI. You may be familiar with BigQuery as a place to store and query your data, but in fact, it's also a unified and pretty robust platform for ML and AI workloads. So the AI is built in, meaning that Gemini models are literally a few lines of SQL away. You don't have to build complex pipelines to move data to an AI model and then back to BigQuery. It's multimodal, meaning you can store your regular tables right alongside things like PDFs, images, audio files, and then you can query all those data types in one place using SQL or Python. It's serverless, which you probably know from the storing and querying data space, but you don't pay for idle servers. The platform automatically scales up as it needs to handle a big job, and then it scales back down to zero. So this means you're not worrying about bringing up any infrastructure or managing any infrastructure yourself. When we talk specifically about BigQuery AI, its capabilities really fall within 5 main pillars. So the first is predictive ML. This is generally for building models off of your tabular data, so you can handle everything from feature engineering to model training. You can also deploy models for real-time prediction on endpoints. And with all of that, you still don't need to move your data. You can do it all in place in BigQuery. Then there's generative AI. So BigQuery is integrated with Gemini models, which means you can apply them directly to your data via SQL functions and use that to analyze your data. You do have model choice beyond Gemini models, so this also has options for open source models or third-party models like Claude, for example. There's also vector search, which is about discovery, so you can generate embeddings within BigQuery and then perform vector search, keyword search, even hybrid searches, all within BigQuery. And then in the agent space, BigQuery's been releasing new agents, things like conversational agents for data, specialized agents for data engineering or writing data science code, as well as a bunch of tools around building your own data agents. So in this session, we're really focusing on the first 2 pillars, the predictive ML and the generative AI functions. And the demo actually that I'm going to show later will also include some about vector search and embeddings, though I won't go into those as in depth. So that's the platform. Let's talk about the first big pillar, which is predictive ML. So this is often what businesses need first. It's answering questions like, is this customer going to churn? Or how much inventory will we need next month? How much are we going to sell? So historically, this was hard because you had to move your data out of your database or data warehouse into a separate ML tool to do that predictive ML development or model development. But now you can do it directly where your data lives in BigQuery. So what does it look like to create and use predictive models in BigQuery? Let's take a look at this penguins data set. This is a traditional classic hello world for data science, but you can imagine using your own data set as well. and you want to predict a specific value, maybe the body mass. With BigQuery, you can train a model to predict this value using a single SQL statement called create or replace model. So you'll specify the model type, in this case, linear regression, the column you want to predict, which is the body mass. And when you run this query, BigQuery will spin up the infrastructure, train the model, and then shut down the infrastructure. So once trained, then you can use this ml.predict function to generate forecasts for the new data rows immediately. So really being able to build models this way expands ML access. So you don't need to be an AI engineer. You don't even need to be writing Python. If you know SQL, you can start building and deploying ML models with BigQuery. So that was a very simple example of creating the model and then predicting on it, but BigQuery offers a lot more for the entire kind of journey. So you don't have to stitch together a bunch of different tools. So it does feature engineering. This is usually a very labor-intensive part of kind of manipulating the data. But in this case, we have built-in functions to help you clean up the data, resize images, bucketize numbers before training. Then for training the model, we support all the major algorithms like ARIMA models, k-means clustering models. You aren't managing the infrastructure for the training. BigQuery handles all of that in the background. And then once you've trained your model, managing it, BigQuery can easily register models to the Gemini Enterprise Agent Platform Model Registry. You might know that as the Vertex AI Model Registry, but it recently had a name change at our big conference a few weeks ago. And here you can register the model and, track it. And doing that just takes a quick parameter, adding a model registry option within the function, the create model function itself. And then finally, inference. This is really the most important part. You're using the model. You can do this in batch, running in BigQuery, or even in real time. So some of the use cases we see customers using predictive ML for. Forecasting is huge. So this is, think of retail or supply chain, predicting sales, how much inventory you're going to need. Under the hood, this uses ARIMA-based models that can handle seasonality, and it can forecast thousands of products at once. So it's creating forecasts not for just one product, but for thousands. Anomaly detection. So if you're trying to answer questions like, is this transaction potential fraud, or is a machine sensor acting weird or out of the norm, you can do anomaly detection, modeling, classification. So sorting things. Is this a high value sales lead, a low value one? Clustering. We have a great tutorial actually around clustering your customers into like segments. So you can kind of target weekend shoppers with different campaigns as like discount hunters, for example. And then recommendations. So using matrix factorization, you can build smart recommendations like, what you see all the time. If you bought this, maybe you might want to buy this. So as you can see, there's tons of powerful ways to use these really simple SQL functions within BigQuery ML. So I also wanted to highlight something really exciting here called TimesFM. I don't know if you've heard about it, but this is a foundation model for time series forecasting. So instead of building a traditional ARIMA forecasting model, which requires a lot of history to train the model on your specific data, TimesFM is a pre-trained model from Google that's been trained on, I think, 100 billion real-world data points. So it really understands trends, how they work conceptually, and this means you can kind of do zero-shot forecasting, meaning you just give it the little data that you have, and it predicts future values without needing kind of a long training cycle. So this can be a really good shortcut. You can try it. I think I, had a demo last year where, you can try this first, see how it works for your data, see how accurate it is before you go and building kind of a larger training and ARIMA model yourself. And kind of in the same vein as TimesFM, Tabular FM and BigQuery is coming as well. So this is a pre-trained model, but instead of for forecasting tasks, time series, it's classification and regression on your structured data. So this would be comparable if you're familiar with XGBoost models, which actually is what I am going to show in the demo. But it can be even more accurate than training those custom models yourself, and even on really challenging data sets. So I wish I had this to demo for you today, but more on that to come. Now let's talk about the next pillar, which is generative AI and BigQuery. This is where things, I feel like, get really fun because you're bringing the power of Gemini models directly to your BigQuery data. So I use Gemini every day on work, personal life, everything. So it's really fun to kind of have that ability to do anything you want, but on your BigQuery data. So BigQuery is integrated with this Gemini Enterprise Agent Platform, Vertex AI, formerly known as Vertex AI, and this gives you a way to consume LLM models directly from BigQuery. We have a few different families of functions that access these models. First, the general purpose AI functions. These are give you the choice of, they have a lot more knobs and buttons. They really give you the choice of models, full control over prompts, advanced settings like temperature. So these model, you'll see in some of the example queries, you're defining a lot more of what you want within that function. We also have managed AI functions, which are newer. So these, as we see common use cases or tasks, we've built kind of these functions that are optimized for those specific use cases. And it really means you can write them much faster and use them much faster because they kind of do a lot of things in the background for you. They've been optimized, so you can just kind of throw in your natural language prompt and go. And then we also just announced AI.parse document function, which is really around automating OCR, doing layout parsing and chunking. So that can really help if you're doing like RAG workflows and you need to parse documents and embed them. So we won't get into that today, but it's definitely something to look at since it's new. There we go. So starting out, I want to just take a look at our general purpose functions. So this is that AI.generate that I talked about, and how you can kind of add all of, it has all of the knobs so that you can dial it in the way you want. So this first code sample shows how you can use AI.generate within your select statement. You can just pass in a prompt. In this case, my prompt is going to be summarize in one sentence, and then passing one of my columns, body, which this is from a BBC News data set. So this is like the body of a news article. And then I can have it summarize each of those articles, the long body of text for each article across, thousands of rows, but it could be millions or even billions of rows. The other very useful feature, especially since we're working in a data warehouse, is the ability to define an output schema. So this basically forces the LLM to provide back a strict format for your question. And we'll see an example. This example is probably not the best one, but we'll see an example of this in my demo so you can see what it looks like. All of these functions work with data in BigQuery tables. They work with the structured data you have, but also the multimodal unstructured data that I mentioned earlier. And that's through a data type we have within BigQuery called object-ref. So I want to do a bit of an introduction to object-ref data type because this is relatively new. Many of you probably haven't worked with it. You might have worked with object tables, but this is definitely much more flexible, though it does take a little bit getting used to. It launched, I think, about 1 year ago, I think in May of last year, right after our next conference. So object-ref is a struct, and it contains data about an object that you've stored in Google Cloud Storage. So this struct includes data like the object storage URI, access control metadata, standard GCS metadata like the size, the content type, and then also any custom metadata that you might have added in Google Cloud Storage. So it's a very versatile and composable data type because you can move it across tables. You can create it as part of a transformation, so it can be used in ETL pipelines. You can create BigQuery tables that are a mix of structured, tabular data columns and then object-ref columns. And you can have arrays of object-refs within a column. And because this data, it can all be stored together. You can run a multimodal analysis. So for example, this query shows how to combine kind of a few tabular data items, like, filtering on a category and a return rate, with one of our general purpose AI functions, which returns, a bool. So in this case, I'm basically looking for any of my products that are in the electronics category with high return rates, and then also filtering on where the images of returns from customers. So these are images and videos provided by customers have shown sign of damage on arrival. So this is kind of where you can start to take, just natural language filtering across multimodal data, and add that to kind of your like standard where clause, like with structured data. So what are some of the features using Gen that you can kind of, push and pull when you're using these Gen AI functions? We've talked about most of these, but just all together, again, I mentioned the choice of LLMs. You can use Gemini. We have third-party models like Claude, and these are both model as a service from Google. You don't need to deploy them. They're just like at an endpoint ready for you. But you can also use any Hugging Face model. So BigQuery gives you a SQL interface to deploy and use models from Hugging Face, where they get deployed to Model Garden endpoints, and then you can use them in BigQuery. So you can kind of set all of that up from within BigQuery. Another feature is the structured output. That's what I showed you earlier. So this is an example of, if I'm generating a patient description and I'm pulling out of the patient description various things like name, age, and phone number. You don't really want a big paragraph to come back from the LLM. You want specific columns or JSON values that you can, join with your other tables. It's also multimodal, so you can work with content beyond text. That's using that object ref that we talked about in the last slide. So you can use LLMs to analyze images, video, audio, not just text. And something we haven't talked about yet, but is very important, is from a cost perspective, BigQuery uses the Gemini batch inference if you're using the Gemini models, which is 50% cheaper versus online inference. So that's a huge advantage if you can do this in batch and BigQuery, to being able to kind of like manage costs when doing LLM inference. So those certain common tasks that I talked about earlier, we've started releasing as specific AI functions that we call managed AI functions. This way you don't always have to write a long, complex prompt and dial in all those parameters yourself, like picking your endpoint or, setting different things up, like even, defining that output schema. Like these have potentially, defined schemas as part of them themselves. So they also rewrite prompts to improve accuracy and reduce costs. So there's a lot going on the back end when you use these, and you can see that they're quite quick to use. Like you don't have to type in a lot. Like you can just add your natural language prompt. You can add, for classify your categories and what you're categorizing. So I'll run through these a little. So AI.if is kind of a dual purpose. We have what I'm showing here is a join. So you can, do a semantic join, if you will, which you can see as this sample. But you can also use it as a semantic filter, like we saw with that generate bool. This is somewhat similar, where you can put it in a where clause and you can run a query with a prompt that says, if I have a bunch of customer reviews, I could say like where AI.if and then customer sounds angry and pass that review or pass a call transcript, for example. And then you only get back the rows that are, equivalent based on what the LLM thinks about the customer sounding angry. There's also AI.classify. This is a really popular one. It's a very quick way to automatically bucket data into categories that you define. So like that news article data set we saw earlier, you could take all the bodies of those articles and have the model classify them as tech, sport, etc. And then AI.ag, AI.score, which I think is also in the demo, basically helps you evaluate rate and rank unstructured data like text or customer reviews based on your criteria. So this is just a way to like provide a ranking. It can help you kind of surface things to the top of like maybe a big table if you're looking for, top sort of things, but using a natural language evaluator. And then AI.ag, which is our newest function, and it's our first aggregate function. So this, instead of having a row-based evaluation, this really can summarize across, thousands or, millions of rows. So you can take, say, 10,000 rows of reviews for a single product and condense them into a single paragraph summary of top issues. You can do that where it aggregates with a group by. So you can have it, in one query, it can group all of the reviews by product and return kind of the top summary items for those. So these managed functions are really optimized for scale and cost. They're meant to be for specific tasks, and through that optimization, they generally run faster and cheaper than writing something through one of the generalized functions. They also use the batch processing behind the scenes. So that's, again, that advantage of that 50% discount on Gemini models, because these functions do use the Gemini models. To build off of that kind of optimization theme, we did just announce at our conference a few weeks ago for two of those managed functions, AI.if and AI.classify, there's this new optimize mode. So this mode was created to even optimize further for speed and cost when running functions over really large data sets. So think like in the millions or billions of rows. Normally each of those rows would be sent in batch over to Gemini. But in this case, when you're using optimize mode, BigQuery just sends a subset of your data to the LLM for labeling. It then takes that subset of data to train a distilled model within BigQuery itself, and then processes the rest of the data against the distilled model. So this is really showing massive cost, latency, and scale gains. So you're going to be consuming many, many less tokens to process, and it's going to execute much faster. We actually have a video out about this, so definitely check that out if you're using these two functions. And again, it works on text or unstructured data. You just need to provide an embeddings column. So you'll see here, we're kind of pointing to this embeddings column. So if you have embeddings for your data, or you can embed them on the fly like is done in this query. So we basically use this AI.embed function and an embedding model endpoint to add that inline. So use cases with Gen AI and BigQuery, we see several things happening. First, entity extraction. So you're pulling information out of unstructured text or images. You can point a model at a folder of car photos and ask which part is damaged, or scan receipts and extract the total amount. Data enrichment, which is kind of like adding new columns and new information to your existing data set. Sentiment analysis, instead of just saying, is this positive, is this negative, you can really understand the nuance. So for example, you could draw out from a review, you could draw out sentiment about the product versus the shipping versus the customer service, and kind of get those signals separately. And finally, you can use LLMs to summarize content, very much like we saw in AI.ag, or use it to enable RAG through like creating embeddings and having vector search. So now I'm going to head into a demo that really brings many of these capabilities together so we can see how they can be used together, how they look in a real project. And we're going to do this by looking at Symbol Autos, which is a marketplace for vehicles, and we're going to have BigQuery automate kind of that expert intuition required to navigate a marketplace like that. So this demo shows generative AI to analyze raw images. It shows semantic search with embeddings and vector search to understand buyer intent. It also uses embeddings and vector search to identify kind of scam risks within listings. And then it also predicts fair market value of the vehicles using that the first category we talked about, which was predictive ML. So these tools kind of all together are helping us surface hidden gems and flag kind of like high-risk lemons on the website. So I'm going to go over to the demo here. And this is our symbol autos. So here we have several marketplace listings on the website. You can see here, I want to start here with the search bar though. This is kind of what I talked about with semantic search. So this isn't just keyword search. This application runs on BigQuery vector search. So for example, I can put what I want the vehicle for. I'm going to put furniture delivery business and search the inventory. And you can see when the results come back that the semantic search is really understanding our actual intent and doesn't rely on keywords. Like none of these keywords are going to be showing up in these listings likely. So it returns vehicles that are able to haul large, bulky items, trucks, truck beds, things like that, even though we didn't type those words. So I'm going to zero in on this really interesting hidden gem because I love that this hidden gem has kind of maybe not the best photographer, but let's check it out and see what it looks like. So it has the deal score of 90, which we'll talk about how that's evaluated, but it's not, this kind of gives you a sense of what data we have about the vehicle. We have several photos or images, and we have some text information, and then we have this information here. Well, we have the listed amount, the price, and the type, and then we have this panel here, which is really the insight we're getting from BigQuery AI. So this deal score isn't just one metric. It's actually a composite of the metrics we have here and a few other things. So the first is our predicted market value, which it checks if a car is priced fairly. Then we have a visual condition, which uses BigQuery AI to physically inspect the photos. And then the third is this authenticity score that compares the description of the listing against kind of known scam listings. And you kind of might wonder, like, why do we need to build this? Why not just look at the price and pictures myself? But I think anyone who's kind of shopped for things online know that the surface level listings aren't always telling kind of the truth. A listing might look really good. It might look like a great steal with great pictures, but when we run the description through, it like actually looks quite like a known scam, and that's not something you might always identify. In this case, you might miss the listing because the photos aren't done well, and AI can really kind of like get through that bias when it kind of actually looks at what's happening. So let's go dig into kind of how each of these market value, visual condition, authenticity score, and the final score are created using BigQuery AI. So I'm going to head over to BigQuery where I have a notebook that just kind of does zeroes in on some of those calculations. I want to start by looking at how we developed that visual condition score. So this was here, 72 out of 100. And that's, again, using the raw images and using object ref. So we have the images for all of the vehicles in this Google Cloud Storage bucket. And that means we can access them in BigQuery automatically without building any pipeline. So we can create basically a table that contains an image ref array that points to all of those vehicle images for each vehicle we have a function in BigQuery called object.makeRef. And you'll see once I've made that table, this is what my image ref column now looks like. It looks like an array with several different URIs pointing to images. And this information basically makes these images accessible to BigQuery for analysis. So because of that direct connection, we can now use AI.generate to analyze those images right here using a model, a Gemini model. So you can see here I can create a select statement that for each of the listings then prompts over the image ref. So again, this, remember, is all of the images for that vehicle. and it can prompt it to rate the condition of the car on a scale of 1 to 100, and then output a description with red flags. So I'm actually asking it to do two different things, and I can define that output schema that we talked about earlier to put the condition as a numerical value, and then that description as a string. And when I run that query, which I won't, it said it took about 15 seconds, just so you know. But you can see now for each of the listings, I now have a condition value and also the description summary of like potential red flags. So that output schema parameter is just so important for somebody working with data. It completely forces the LLM to return this cleanly formatted score and short summary so that we can use it further in the way we want to. Another kind of visual check that I'm going to do uses AI.classify. So this is the one that categorizes that we saw earlier as a manage function. So in this case, we'll again pass, in this case, we're just going to pass the prime image, the first image of the array, and ask it to provide what type of automobile it is within specific categories we define. Also providing the color, exterior and interior based on a set of specified categories. And we can see that this pulls that data out. Like I would say this was like kind of an entity extraction exercise like we talked about earlier. And this data actually isn't going into the visual condition score. You're going to see that we actually use that when we predict the fair market value, but it is kind of supplementing the information we have about each vehicle so that we can then evaluate its fair market value. So, and that's what we're actually going to do next. So let me scroll down here. This is all about that traditional predictive ML process, and we're going to actually build an XGBoost model to predict the fair market value of the vehicle. So we have an entire data set of our listings, but we need something that's told us, well, what do cars sell for? So we have a data set of 100,000 historical vehicle sales in a separate table, and we're going to use that to train a model. So you can see here, this table, this is the information we have, the different features we have for each car that we can train for a model. You can see here we have the condition and as a score, and the interior and exterior color. Well, I assume we have the exterior color somewhere here, but body style as well. These are the things that we, tried to supplement in our listings so that we could eventually use those as we predict the price, the fair market value. But we're going to start out with these known sales, and then we're going to train an XGBoost model. So this is that create model statement we saw earlier. This does take a while to run. So as a demonstration, I haven't been running it. But you can see here the query itself is very, very straightforward. And this, I can run. And then once I have that model output or fully trained, I can then use the ml.predict function to provide to do predictions for fair market value over my listings data set. So that's what I'm doing here. I'm using the model I just trained. I'm taking my listings data set that has all of my additional features like interior color, condition, exterior color, type. And this query will then, I think in just a few seconds, return for each of my listings. I guess I have 127 listings, a predicted market value. So this all contributes back to the price score and the deal score that we'll see in a bit. The third item is looking at how embeddings can actually enable a couple of smart features for a marketplace. The first you've already seen, it's that semantic search you saw in the front end so that somebody can input natural language and text and match that to vehicle photos. And that's via multimodal embeddings. So we can use the AI.embed function on our images. So these are the images of the cars and embed them against a multimodal embedding model, which means you can use text and images, or you can use text or images, and basically compare embeddings across a multimodal data. So this is an example. I'm not going to expand it because these have many dimensions, but what we've done here is we've embedded the images for each car into a multimodal embedding space. This is transformed, kind of this selection of images into a coordinate map of numbers that captures kind of the underlying semantic meaning of what we passed it. So then when the user provides the query on the front end, like I did earlier with furniture delivery business, we can then do the same thing, embed furniture delivery business with AI.embed. So that's embedded in the same kind of embedding space using this multimodal model. And then we can use vector search, which is one of the functions within BigQuery, to find the closest vehicle matches to our text query. So that way, when we run this query, these top 6 listings are probably what I had over here in the website on the when I first searched, and I had those initial listings. So this basically evaluates what do I return the user when they're looking for furniture delivery business. The other thing that we can do with vector search and embeddings is develop kind of a risk analysis. And this is basically what we're turning into this authenticity score. So instead of looking for comparing images of cars with a search query, we're actually now going to look at text-to-text kind of embedding comparison. And in this case, we're comparing known scam descriptions with the description of our listings. So the first thing, this is what we've loaded into our kind of scam data set of like different descriptions. We also have a few like enthusiasts. This would actually be something we could use to find like kind of more hidden gems. Like this is what people that are car enthusiasts tend to post. But in this demo, we're really focusing on scams and making sure that none of our car vehicle sale descriptions match closely with these. So we are going to embed all of our, I think we actually, maybe I already embedded those. So we basically embed each of these against a text embedding model. So you'll see instead of that multimodal embedding model, we'll do a text embedding model, which is much better if you're working with just text. And then we'll use vector search to develop our authenticity score. Again, looking for, for a specific vehicle, what is the closest scam to it? So for this vehicle listing, the closest match was, this specific distance away. And you can see as we are closer, the authenticity score is lower. So if you're very close to a potential scam, it's going to return a lower authenticity score. And this gets scaled because all of these things are kind of close together in the embedding space. All right, so now we have kind of all of these scores created, and the final step is to merge them all into kind of these AI signals into like one deal score. And what we decided to do in this case was really just combine these signals at different weights into a deal score. So we have a price score we developed that then gets weighted in at 40%, and that's based off of fair market value. We have the vision score that's based off of that condition that we asked earlier with AI.generate. And then we have the authenticity score that we just did on how much of a scam risk it is. So one final item, because we hadn't used that description, I think the vehicle details here, other than for looking for authenticity, we also wanted to make sure, hey, if the sellers said anything about the condition that's useful, let's like throw that into the deal score. This is the most mathematically fancy deal score we've ever created. No. But what's cool is you can actually add that in on the fly and this using AI.score. So that's what I talked about earlier with, ranking. I can just throw this in here and ask BigQuery to rate the vehicle condition based on the text provided in the description. And then I can include that as one of my components. So I do that. I also have a price score based on the predicted market value and the current price that really is kind of rewards underpricing, but doesn't have too much of a penalty for overpricing, because of course you can always negotiate a little bit. And then they all get placed together here in this one query. And you can see in the results, we end up with each of our listings now have the various individual scores, but also the final deal score. So that's really kind of jumping back into our marketplace. You can see we've found this vehicle. For our furniture delivery business, we know it's at a great price. We know it's kind of low risk for scam. And based on, the visual condition, it was bubbled to the top. So yeah, kind of showing a lot of those items together in one place. So let me go back to the slide deck real quick and we'll finish up. So as you can imagine, there's a lot to think about when you're actually using these in a production environment. I did want to call out a few items and a few new items that are going to help in that area. So first, one of the most important things to get a handle on when you're using this, especially at scale or in production, is on your token spend. So we did just announce at our conference a few weeks ago new features which are rolling out kind of this month. The first, which I know everyone's going to be very excited about, including me, is a new function called AI.count tokens. So this is a function you can use to quickly tell it, and it will tell you your input tokens for your prompt and what the input table, like the data you're passing as part of the prompt, will cost. The second is project and user level token controls. So this means you can set per project per day, and per user data controls on input and output tokens. We've had this kind of control in the past, we still do, for query usage, if you've used that, which we highly recommend. But if you've used that in the past, you can kind of imagine like having this ability, but for token usage. And then third, we're adding the ability to set input and output token controls at the session level. So you can see in this example query how this could make, you can add these to your queries as you're developing, and it can make it much easier and safer to kind of like limit these sorts of things in real time. And all of these are really focused on having like finer control as you develop with these AI functions, because, you're doing it over really large data sets. I also want to talk about how you build these into pipelines. So in the case of the demo, for its simplicity and learning, and you'll see it's something that we have a tutorial so you can bring up yourself. The data pipeline was processed as like a one-time batch inference. So, in theory, cars are going to be added to this marketplace. These things need to be evaluated, not as a batch process. And the good news is that BigQuery AI functions are surrounded by the BigQuery platform. So you have a lot of options for building them into a pipeline. So starting with processing of streaming data, you can actually use these functions with BigQuery's continuous queries capability. So as the feedback, say in this case, as feedback arrives to your table, it can immediately run sentiment analysis and insert it back into an analyzed table. From a data pipeline perspective, you can use Dataform. There's also some templates for Dataform out there. You can schedule queries using BigQuery pipelines. Or you can use managed service for Apache Airflow for a more complex orchestration. So I hope this was helpful in getting a better understanding of what BigQuery has to offer in the area of ML and AI, how you can use those capabilities to get value from your data, get insights that you couldn't get before, and how quick it can be because you're not moving data, you're not having to write code, you're just writing SQL. I really, really encourage you to try these features in your own environment. I have a bunch of documentation links and tutorial links provided. And then if you actually want to bring up the symbol autos demo, we have a tutorial here that takes you through every step. It speeds you through the boring parts with some setup scripts, but lets you kind of dive into like how each of those functions are used and created. And I think some of these notebook tutorials here really go into a lot of the the extra, how to use object refs, how to create object refs from, string URIs that you have in your data, for example, all the different AI functions, when to use the managed functions versus the general purpose functions. So there's really a lot of great info in these notebook tutorials. In the Symbol Autos demo tutorial, it even shows you how to get some coupon credits so you don't even have to, pay for it. So highly recommend you follow those and ask any questions you would like. So thank you again for coming.
Well, Alicia, thank you for that. That was really, really interesting. And I know starting at the keynote, we were all really interested in AI functions and all the capabilities that are being, kind of brought in to the BigQuery ecosystem to see it all put together. Really, really cool. So thank you for that.
Thanks. Yeah, I was really happy watching the keynote. There was so much content there, and I felt like a lot of the questions were about the AI function. So that was really cool. Lots of interest.
Yeah, and I mean, you could see why, right? Like, I think especially seeing the AI functions is like you would think, AI if it's something really, really simple, but that's a pretty powerful thing to be able to, like have that kind of SQL if
Yeah,
query
your where
functionality there.
clause can be like anything. It doesn't
Yeah,
have to be, a specific, like greater than a certain integer amount. So, yeah. And
absolutely.
those are fairly new. So I think a lot of people don't even know as we add these managed functions, there's so much information coming at us every day. So, and these are kind of like net new uh, abilities. It's not like, oh, let me use this thing because it works slightly better. So I think people have to start thinking about as we are doing everywhere in our work lives, like rethinking how they do things and seeing new functionality and how they could take advantage of it. So, like for
Absolutely.
example, like object ref, I think it's actually, I find it quite confusing. I still think from what I hear from our product managers, most of usage of these functions is still text only, or it doesn't take advantage of the multimodal capabilities because people probably aren't used to analyzing multimodal data in BigQuery. But it's, as you can see from the lake house and everything that's coming together, it's really going to be a place you can analyze all different types of data and start getting used to thinking about that and not just your rows and your columns.
Mhm. Absolutely. And I think, and you were really great about answering those questions both in the chat and the Q&A during there. And a lot of them were around you bring up the point, right? Like you have this new capability, and when you're writing queries, when you're using BigQuery, where you can start to use AI generate or use the AI functions, the pre-built ones. I one thing that came up based on the questions that you talked about was this idea of how do we need to think about performance? Because I can imagine myself now, I'm gonna stop I don't want to, right? But I might stop thinking, oh, how am I going to actually formulate this query to be done in a performance or cost efficient way and just write
Mhm.
generate and if and score. And so should we think about that? And then I imagine the other capabilities around like query planning and generating, which we can also leverage AI for, can probably help us do that, right?
Yeah, so I think um, my suggestion around like using generate and I think it's still quite new for me even and like figuring out when to use it versus not. We started out in BigQuery and we had these kind of task specific functions which people might have seen or might not have seen, but they basically had very specific, they used um, very focused AI models to do things like sentiment analysis, or it even had visual, different visual things. You could identify categories of an image, or you could identify objects in an image. But they were very specific, and I think they still exist today, and they had very specific capabilities. And so I think sometimes you might be doing like a one-off analysis, and if you, as long as you prepare for what the cost would be, and I think we're adding new functions like the count tokens function actually is out now,
Mhm.
and that is focused on input text input. But I think the team is really working to expand that. But for a one-off thing, it might be easier to just kind of use these generate functions. If you're building like a recurring pipeline, you might
Mhm.
want to take a look at like task specific functions and especially price. I would say though that these generate and the LLM cost has come down so much. I don't know if those task specific functions are really like worth it in the end compared to what the LLMs can do. But there's also, that predictive ML we talked about earlier with BigQuery ML and building a model. So you
Mhm.
can also potentially, if your use case can fit within that and it's a better cost scenario and you're running that model within BigQuery compute and inferring within BigQuery compute, that might be better for something you do over and over. But I certainly think AI.generate and especially these managed functions that you can just on the fly try out are really good for ad hoc analysis. And I don't think
Mhm.
there's a reason they couldn't potentially be good to, run over and over. I think we don't mention it enough, but when you use BigQuery with these functions, you get the batch pricing
Mhm.
with the Gemini models, which is 50% of the list price. And so they really can be performant from a cost perspective. And like Thomas said earlier, there's a lot of work going in to making these functions run faster and kind of just be optimized to be able to return within kind of the expectations of like a BigQuery user. So yeah, it's definitely, every use case is different. There's also really cool things. I don't know if it's anything you can do in Gemini, you can do in BigQuery with Gemini. But there's
Mhm.
even something I hadn't used before called context caching. So my teammate Rachel Deacon Smith just wrote a blog post on this. Basically, you can do context caching with Gemini, where you have basically kind of some sort of content like a PDF file that goes with every prompt. And that's, I think, 90% off of kind
Wow.
of like tokens. So if you're passing something but through every row of that LLM call with BigQuery, and maybe it's like a lot of context in the form of like a PDF or something like that, you can actually set up this context caching, and that reduces the cost. And it makes it much faster as well because it's
Mhm.
handled differently by the model. So yeah, there's a lot of ways if you are going to do something over and over, like you start to like read up on that or even just chat with Gemini about how to make it a little bit better.
Okay, that's a really great point. And I wonder, Alicia, if you're willing, because I think there were a lot of questions that were around, how you actually built out the demo and what went into that. And even, I mean, I think that there was one question kind of talking about, what happens if I build a web app or some type of flow that's
Mhm.
directly hitting BigQuery. How would you be willing to have a maybe 10-minute discussion just about that, the process that went into it? Um,
Yeah, yeah, I'm happy to chat a little bit more. I mean, we built this demo. It's like
yeah,
I'm happy to have it live in more places than just the past floor of the
absolutely.
next of the next conference.
Absolutely.
Uh,
So I think, one thing to keep in mind in general, right? Before we jump into how you did it, if you use like anti-gravity or Gemini CLI, anything that people should think about, developers should think about, because obviously we know that we just talked about if we're using the AI functions, whether we're using AI generate or the managed functions, if we're just doing some analysis and trying things out, that's fine, right? But when we actually think about an application or a workflow is running against BigQuery in the back end, things we should think about as we're kind of building out an application, looking forward.
Yeah, I think I see mostly like what people experience in the prototyping phase. Just I think the nature of my work and maybe the
Mhm.
nature of where people are at with like including these functions.
Mhm.
And I think, like I did when I built this demo, and like I do anytime I'm working with a new data set, is we prototype on a small subset of the data. I might just do a few rows, like every time I send a prompt through these. And then I might try it with, 50 rows to just kind of get a sense of how long does this take to run at a certain data size. And then once I have the prompt working, I also have to remember that running it on a few rows or running it on 50 rows really it doesn't prepare me for running it on millions of rows necessarily because
Mhm.
the data is unstructured. When I scale, there's going to be a lot of variance beyond what I see in just those few rows. And so really being understanding how like nulls work, how the errors work in these functions. If I get a null, how is that going to happen? I think there's some nuances between how the general purpose and the managed functions handle errors and nulls. So kind of, and there's some great documentation on kind of like, for example, AI.if I talked about. There's a general function called AI.generateBool, which is kind of the same thing, but has all of the bells and whistles of those general purpose functions, but they handle kind of errors and nulls differently. So it's interesting, like it's important to see how that works and be prepared for it when you're running something over like very large data sets. Yeah, and then the other thing I just see people as I would suggest always starting with a managed function if it works for you. Um, it's kind of like, and I don't remember if I talk about this like with the Times FM versus building your own ARIMA model. Like sometimes I'm like, do the easy thing first. See if this works for your time series model before you go to something else. Um, just because it's much faster to write and it's getting a lot like this optimized mode that I talked about. That could save huge because you're kind of bringing the processing into BigQuery and away from that API endpoint that has kind of, like a cost associated with it. And so it's like you don't always need AI.generate, but it's always there if you need to kind of like move towards it and or AI.generate bool to have that. So I would say those are kind of some of the things I see when people are starting out. And it's just hard to stay up on, you know, there's not a managed function today and there is tomorrow. It's kind of the same thing with like the model, the Gemini model can answer, last week I tried to have it help me do this, it wouldn't work. I have to
Mm-hmm.
forget because I'm so used to giving up on things, and thinking it'll never work for me. But actually, with LLMs, I feel like they learn very fast and things are changing every week. So not kind of giving up on it and like continuing to consider it in the future as things
Absolutely.
change.
So with that being said, if we think about, building the demo, so in this case, right, thinking about from a vibe coding perspective, and we actually have a question about an agentic workflow for this, but let's just, I
Mhm.
guess, take it first from the perspective of, as a developer, a human sitting there and developing something like this. If I were to use, anti-gravity
Mhm.
versus Gemini CLI, what's the difference, I guess, as a developer in choosing either of both of those tools?
Yeah.
Where do one of them shine in for a particular type of workflow?
hmm
And then maybe
Well, I
after that
think,
we could talk
yeah.
about agentic flows. Yeah.
Yeah, I think at least my personal experience with these kind of like Gemini CLI or anti-gravity is like, where do I tend to work and like, what's my workflow and which one works the best with me? So a lot of people that work at the command line really love Gemini CLI because that's where it's at with them. Um, Anti-gravity has been good for people that work in VS Code or we have a new data cloud the Data Cloud Agent Kit, I think. Data
Mhm.
Agent Kit. I need to know the name. So we basically have this new extension just got released at Next that you can add onto VS Code, and it basically brings like all of the MCP servers, a bunch of skills, like everything you need to function as a data practitioner, like presets up your environment.
Mhm.
And that's also and you can use that with Gemini in your environment, or you can use it with other models. And so I think it's kind of like whatever your development workspace is, like how you can add on that agentic kind of helper without kind of feeling like you have to learn something completely new. So I would say I haven't been using Gemini CLI as much as I've been using something like anti-gravity or Data Agent Kit.
Mhm.
I also use Gemini in the browser a lot because a lot of the stuff I do is making content. It may be related to producing code, but it may not. So I also use Gemini in the browser. I don't use Gemini in, I also use it in BigQuery. So this is another example of like where you give up on something and then it gets better. So like all of the assist functions within BigQuery console, because I'm a big Power Console user for BigQuery.
Mhm.
Um, you know, I kind of gave up on it, like to be honest, early on because it just wasn't working and it didn't have the context I wanted it to have. It's sitting in BigQuery. It should know like what I have access to and what my data sets are. And now it does,
Mhm.
finally. So I think like it took me a long time to realize though, because I had kind of moved my workflow to use it elsewhere. So I think it's kind of interesting. So I think wherever you're at, and of course I/O is today, so there's going to be a lot more announcements, I'm sure, about kind of where these things are at and how they can help you. But yeah, it's I guess change is the constant with this stuff.
Absolutely. And I mean, hearing you talk about data agent kit extension, and sometimes can be like this, in the Google world and like
Oh
anywhere in the
yeah.
cloud with names.
Oh my
I
gosh.
we had a question about the ADK, so it would be a little bit
Mhm.
switching away a couple of the letters. So Adam asked about if it's possible to build multimodal pipelines and BigQuery AI functions in an agentic way using ADK. So I guess more
Mhm.
generally, is there a way that ADK kind of plugs in here or talks further about
Yeah, I
BigQuery?
mean, ADK, you can. So I've built very few like agents with ADK so far. So I can give you my experience, but essentially you can give it access to your BigQuery. I believe there's ways to define, somebody asked earlier about kind of like how permissions are observed and things like that. So I think a big question around ADK is like, well, how do you define the user and what the user can access. So like what the agent can look at, and then what the agent can define or give back to the user based on who they are. So these are things that I haven't done in that depth yet, but there's certainly ADK can access BigQuery. It can use these functions. Um, I think you tend to define, like, you can kind of provide extra information, I think, so that they know how to use these functions if you want them to. Otherwise, they kind of like figure out the data the way they want, the way they decide. But
Mhm.
yeah, these can be used by ADK as well.
Okay, that's really, really great context. And I think just as a kind of last note, obviously we just focus our discussion now on the AI functions, AI
Mhm.
generate within BigQuery, really, really cool stuff that's been happening. I'm wondering from your perspective, was there any other announcement about BigQuery from the keynote with Thomas or in general that's come out at Next that stood out to you? Um,
Hmm. Yeah, I think I'm excited mostly. So I mentioned. Yeah, I mean, I am so in the AI function world with BigQuery right now. That's like what I focus on the most. And I think Data Agent Kit is big because I could see that. I think as things come out, like Gemini CLI didn't catch me as quickly just because I wasn't working in the CLI.
mhm.
But, Data Agent Kit, what I've worked with it so far is like great because I hate setting things up, and having it just kind of set up for what I need as a data practitioner is great. So I'm definitely excited about Data Agent Kit. I'm excited to see what Knowledge Catalog does. That's another, I think Thomas mentioned that it's kind of, the rebranded name of Dataplex, but it's expanded functionality, and it's really going to help agents understand the data and the semantic meaning of all of the data so it can use it and kind of answer questions back even better. So I think seeing how I want to start to see how I can use that layer more in kind of the demos I build with the AI functions. And I'm also excited about just the additional. So when I think this was last year at Next, or maybe at our big conference, maybe it was even 2 years ago when we just started using when we started showing how BigQuery could interact with the LLMs, everybody wanted the LLM to be able to read the entire BigQuery table or your entire results table.
Mhm.
And these functions have been really row-wise, like running LLMs against kind of a row of data with a prompt. But AI.ag, which I think will be kind of any day now out there for preview use for everyone, really it looks across the whole table. And I think even at when I don't even know how it works. No, it does some like fancy things there, right? Because you can't just send that much context to an LLM on its own and have it know everything there. So, but it's very good at taking, say you have all of your reviews for one particular product, you can just group by and you can have all of that data, and then AI.ag can summarize that for you into like, top themes or things like that to like send back to maybe your product teams. So I think AI.ag, I'm excited about these aggregate functions that can look across the entire data set versus just looking row-wise. So that'll be a fun one to start to build demos with when it's out. I think any day now.
Well, that's awesome. And I just want to say, Alicia, thank you so much, both for the great session and for hanging around to chat and answer questions about building stuff
Yeah.
on top
Thanks
of
for having me.
BigQuery. Yeah, of course.